Hi everyone, for this part of the unit we're going to be looking at isomers. So isomers are substances that have the same molecular formula but different arrangement of atoms in space. Isomers can be categorized into three different types. So you have chain isomers, positional isomers, and functional group isomers. These are the three types, and you should know these three types. Let's start with chain isomers. Chain isomers, they will of course have the same molecular formula, but they will have different number of atoms in the longest chain. So for example, let's take C5H12. There's different ways that we can have that same molecule with different number of carbons in the longest chain. So one isomer could have 5 carbons, another isomer could have 4 carbons, another isomer could have just 3 carbons. You cannot have any less number of carbons. So here 5 carbons, so everywhere will fill up with hydrogen. So this is C5H12. So 5 carbons in the longest chain. So 1, 2, 3, 4, 5 carbons in the longest chain. Another isomer. So here we have 4 carbons in the longest chain, and then 1 carbon can be on a carbon in the center. So we'll fill up again with hydrogen. This is another isomer of that C5H12. So 4 carbons in the longest chain, and then you have that 1 carbon which is branched. So it is still C5H12, but here the structural formula will be different. So there is a CH3 on one of the carbon and the center, which is branched. Another structural isomer is one which has 3 carbons in the longest chain. So 1, 2, 3. But since we need C5H12, so we need 2 other carbons. So we're going to add 1 here and 1 here. So the important thing here is that these 3 molecules, they all have the same molecular formula, C5H12, but they have different length of the longest chain. So this one, the longest chain, has 5 carbon, this one has 4 carbon, this one has 3 carbons, but they all have 5 carbons in total, and they all have formula C5H12. So when you're asked to draw chain isomers, so what you do, you start with the molecular formula. You start by drawing the longest chain, and then you start decreasing the number of carbons in the longest chain until you cannot decrease anymore. So you are going to try to draw the chain isomer for C4H10. So pause the video, try to draw it in your copybook, and then you press play again to see the answer. So for C4H10, you start by drawing the molecule with 4 carbons. So 1, 2, 3, 4. That's one chain isomer. Another chain isomer will have 3 carbons. 3 carbons, a total of 4 carbons is needed, so I'll add 1 as a branched carbon here, and I'll fill up with hydrogen, making sure that I end up with 10 hydrogen each time. So this is again C4H10 and this is C4H10. These two are the chain isomers. Similarly, try to draw for C6H14. C6H14, you're going to have 5 chain isomers for this one. So again, you're going to pause the video, try to draw it in your copybook on your own, and then you press play again to view the corrections. So 6 carbons. So our first isomer will have 6 carbons, one after the other. So 6 carbons, one after the other. Our second isomer will have 5 carbons, one after the other. And then 1 carbon can be, so here, let's put it here. So on the second carbon. And then we can have another one where you again have 5 carbons, but then you have the branch which is on the third carbon. Another isomer would be to have 4 carbons, and then 2 is left. So one will be on this one, and then one will be on this one. And then last one, 4 carbons again, but then the 2 carbons are on the same ones here. And then we can fill up with the hydrogens. Now, if you consider this one, if we keep on moving the carbons, let's say, so we've done, let's label the carbons. So if we've done carbon 2, we've moved to carbon 3. Okay, so carbon 5. We can't move again to carbon 4 because this one would be equivalent to this one. Because we could also number it like this: 1, 2, 3, 4, 5, which would be the same as 1, 2, 3, 4, 5. So the branch here is on the second carbon. So that would be, these two molecules are the same molecules. These are 2-methyl pentane. Whenever you're in doubt if two molecules are the same or not, try to name them. If you get the same names, it means it's the same molecule. So even if they have a tendency of looking a bit different, if we don't show the numberings, they look a bit different, but they are the same molecules because they have the same name. So then we just add the hydrogen to complete the molecule. So these are the 5 chain isomers that arise from C6H14.